In this lecture, we're going to evaluate square roots and higher roots, such as cube roots, fourth roots, fifth roots, etc. Let's start out with an example of something that we know how to do. How about, let's look at 5 squared. Remember, 5 squared means 5 times 5, which is 25. Okay? What we're going to talk about is basically the inverse operation of squaring. Okay? I'll write this down. The inverse operation of squaring is taking a square root. And that's the symbol we're going to use for square root. Example. Let's find the square root of 25. What we're really looking for here is what number must we square to get a 25? Well, we know that from this example. 5 squared is 25. So the square root of 25 is 5. Can you think of another square root of 25? In other words, can you think of another number other than 5 such that when you square it, you get 25? Well, what about negative 5? Notice, negative 5 squared is negative 5 times negative 5, which is also 25. So in fact, the square root of 25 does have 2 square roots. One of them is positive and one of them is negative. But for our purposes, in our textbook, whenever we see this symbol, okay, square root of a number, we're going to assume that it's the positive value. If we want to talk about the negative value, we'll put a negative sign out in front. Okay? All right. So let's do a couple more examples. Square root of 36. Okay? Can we think of a number whose square is 36? Well, notice 6 times 6 is 36. So the square root of 36 is 6. Okay? Let's get a little tricky on you. How about the square root of a negative 4? Okay? So can we think of a number whose square is negative 4? Well, maybe it's 2. Let's check out 2. 2 squared equals 2 times 2, which is positive 4. So the square root of negative 4 is not a 2. How about negative 2? Negative 2 squared is negative 2 times negative 2, which is also positive 4. So it's not that. So notice, remember, when we square a positive number, we get a positive. When we square a negative number, we get a positive. So there's no way that we can square any number and come up with a negative value. Therefore, the square root of negative 4, we're going to say, is not a real number. Later on in the text, we will actually learn how to evaluate the square root of a negative. But for right now, we're going to say that the square root of a negative number is not a real number. Okay? We said we were going to talk about higher roots. So let's look at the cube root. So we read this, of 8. Cube root, or we can say the cubic root. Okay? In this case, we're looking for a number such that when we cube it, we get 8. Well, let's look at 2. 2 cubed is 2 times 2 times 2, which is 8. So the cube root of 8 must be 2. Okay? How about this example? The cube root of a negative 8. Is that going to be a real number? Maybe, maybe not. Let's see. The cube root of a negative 8. Well, can we think of a number such that when we cube it, we get a negative 8? How about if we look at negative 2 cubed? That's negative 2 times negative 2 times negative 2. Negative 2 times negative 2 is positive 4. Positive 4 times negative 2 is negative 8. So the cubic root of negative 8 is negative 2. Okay. Now from the previous example, the square root of negative 4, remember, when we take the square root of a negative, it's not a real number. But when we take the cube root of a negative, we get a real number. Okay? How about if we try to find the cubic root of negative 27? Well, the cubic root of negative 27 is negative 3, since negative 3 cubed is negative 27. How about a higher root, maybe the fifth root of negative 32? Well, the fifth root of negative 32 is negative 2, since negative 2 to the fifth equals negative 32. Okay? So notice, we can take the odd roots of negative numbers, okay? But we can't take the even roots of negative numbers and obtain a real number. Okay? So let's go ahead and summarize here. Evaluating the nth root of a. N could be 2, 3, 4, 5, 6, etc. Okay? If this number is even, square root or fourth root, then a must be greater than or equal to 0. If it's not, then we're going to get a non-real number. Okay? If n is odd, then a can be any number. Okay? Two cases. If a is positive, say 8, maybe the cube root of 8, then the cube root of a, or the nth root of a, is going to be positive. Okay? So the odd root of a positive is positive. That's what this says. Okay? On the other hand, if what's ever under the root sign is a negative number, maybe negative 8, then the answer must be less than 0. The cube root of a negative 8 is negative 2. Okay? But again, if we're taking the nth root of a negative number and our a inside is negative, such as the fourth root of a negative 16, say, well, you cannot take the fourth root of a negative number. We just say it's not real.